Number 1 wants us to rewrite the equation in its equivalent exponential form. Okay, so I look for the base of the log. I know that's going to be the base of my exponential equation. Doing the log on an argument gives the exponent, so that's going to be my exponent. So 13 to the exponent of n equals the argument, so 193. On number 2, they say write as a single logarithm. I'm going to look and see if I have any numbers in front of my logs. I know that those can be moved to the exponents. I usually do those first. So I'm going to have a y to the 6th power. And then the other thing is I want to look at the relationship between those logs. That's addition. That means I can express it as the multiplication of those two arguments and rewrite it as a single log. So that would be log with base 5, because they both have base 5, and then x times y to the 6th power, and at that point I've re-expressed this as a single log. On number 3, they want me to solve this exponential equation. I notice that we have a 4 that's multiplying that base 10. So first thing we want to do before we take the log of both sides in order to get the exponent down is to isolate the base. So right now it's being multiplied by -4, so I want to divide by 4. Multiply by 4. So that cancels, and rewriting it we get 10 to the 7n equals 2. And then, in order to get the exponent out of the exponent, I'm going to take the natural log of both sides. That lets us rewrite the log using the power property. So we have 7n times the natural log of 10 equals the natural log of 2. And since n is being multiplied by 7, and it's also being multiplied by natural log of 10, I'm going to divide by the natural log of 10. Okay, and rewriting that, I get 7n equals the natural log of 2 over the natural log of 10. Then I'm going to simplify that, but first I'm going to divide by 7. So I get n equals, and then I have to pause for a moment and plug that into my calculator, and I get 0.043 for a final answer. And then of course I want to plug that back in to my original equation just to check it, and that works out just fine. On number 4, they say carbon dating is a method of determining the age of an object containing organic material by measuring the amount of carbon-14 present. An artifact originally had 10 grams of carbon-14 present. The decay model describes the amount of carbon-14 present after T years. And the equation's given there. According to this model, how many grams of carbon-14 will be present in this artifact after 10,000 years? So they want to know how many grams are left. So let's substitute that into our equation. We've got 12 base E to negative 0.000121 times 10,000. And using our calculator, we get 3.6, and referencing that back to our problem, that would be in grams of carbon-14.